Hello, in this video I'm going to solve the following problem for you. This is a problem on the topic of complex numbers basics. Let z and w be complex numbers such that 2z over 3w is a pure imaginary number. What is absolute value of z minus w all over z plus w in its simplest possible form? That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly, the answer that you will get is simply 1. Okay, so now let us solve this problem. So we know that two complex numbers z and w are such that if you make this fraction, it becomes a pure imaginary number. Under this condition, we want to determine this expression in its simplest possible form. Okay, what is the meaning of this to be a pure imaginary? It means there exists, this symbol means there exists a number a, in the set of real numbers. This means there exists an a belonging to the set of real numbers such that 2z over 3w is just simply ai. And I is the imaginary unit. Because if I say that my number is a pure imaginary number, it means it is a complex number, but its real part is 0. This is why I can write it like that. And what I need to do is to calculate one of these numbers in terms of the other and plug them here to see if we can simplify it. So for example, here I multiply both sides by 3w, so 2z becomes 3awi, and then z here, yeah, we can keep it like this, and then I start from this question mark, which is absolute value of z minus w divided by z plus w. I want to avoid working with fractions. Of course, I can find z in terms of w by dividing by 2 and plugging here, but I prefer to multiply this numerator and denominator by 2, so it becomes 2z minus 2w, and then it becomes 2z plus 2w. This is exactly equal to the previous one, but now instead of 2z, I can put 3awi, so this becomes 3awi instead of 2z, and then I have minus 2w here, and then again the same story, so 3awi plus 2w. And now what can I do? I can factor a w out in the numerator, then I will have 3ai minus 2, and then divided by, this becomes w, I factor a w out, 3ai plus 2. Yes? But of course, this is a common factor. This can be simplified, so then it becomes absolute value of 3. And if you don't mind, let me write it in a standard form. So in a standard form, let me write the real part first, minus 2, and then plus 3ai divided by 2 plus 3ai. Okay? But we have a formula that we know that if I have z and w divided, and I want to take the absolute value of this, of course, under the condition that the denominator is not 0, I can write it as the absolute value of the numerator divided by the absolute value of the denominator. This is one of the main properties of the absolute value of complex numbers. So I will be able to do this here as well. So this, I can write it as the absolute value of the numerator divided by the absolute value of the denominator. Okay, but what is the definition of the absolute value? Absolute value of a complex number is equal to square root of the real part of that complex number squared plus the imaginary part of that complex number squared. Yes, so this I will do it here. So if I want to continue, this is a complex number in its standard form. This is the real part, and 3a is the imaginary part. So the absolute value of that number becomes the square root of the real part squared plus the imaginary part squared. And for the denominator, I can do the same thing. It becomes the square root of the real part squared plus the imaginary part squared. But you see immediately what's happening, because this becomes 4 and plus 9a squared, even though this sign is negative. But because of this even power, it becomes positive 4. And that becomes exactly the same as the denominator. So it becomes square root of 4 plus 9a squared. So independent of what a is, this is a fraction whose numerator and denominators are equal. So the answer becomes 1. So if this number is a pure imaginary number, then the absolute value of that complex number is exactly 1. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.